All right, today we're jumping into a paper called WisPaper, your AI scholar search engine, coming out of Fudan University and WisPaper.ai.
And this is a really interesting one. It's designed to be a sort of co-pilot that changes how researchers, discover and manage academic papers.
So for that quick 1-minute summary,
Yeah.
what's the big takeaway here?
I think the main thing is that WisPaper is trying to solve that information overload problem by creating this whole closed-loop workflow.
A closed-loop workflow, so it's more than just a search bar.
Way more. It integrates a powerful scholar search, which we'll get into, a library for organizing everything, and then AI feeds to keep you up to date.
And the tech behind it, the special sauce, is their WisModel agent.
Exactly. That's what powers their deep search feature. It's trained with supervised fine-tuning and then this really clever reinforcement learning method they call GRPO, Group Relative Policy Optimization.
And that GRPO training makes a huge difference. WisModel hits, 93.7% overall accuracy in matching papers to criteria?
Yeah.
But the number you really need to remember is for those tricky, somewhat support cases.
Right. The partially relevant papers, WisModel gets an incredible 91.8% accuracy there.
Which sounds good, but you have to compare it. What did the baselines do?
They just fell apart. A strong model like Gemini 3 Pro only got 15.9% on that same task. And that ability to judge the gray area, that's really the whole promise of WisPaper.
Okay, so let's unpack this a bit. I mean, why build a whole new search engine? As a researcher, you've got your Google Scholar, your Arctic, Filters, maybe Zotero.
Sure.
What's the actual problem they're trying to solve that, the giants haven't already fixed?
Well, the core problem is just the sheer volume of papers being published. It's growing exponentially, and it's outpacing our ability to keep up.
So it's a cognitive load issue.
It's a huge cognitive load issue. And the current tools, they fail in a couple of key ways.
Okay, like what?
First, you've got your traditional systems, right? Like Google Scholar. They're almost all based on keyword retrieval.
Which works fine if you know exactly what you're looking for.
Exactly. If you're searching latest paper by Jan LeCun, it's perfect.
Mm-hmm.
But what if your query is more conceptual? Something like, what are the ethical problems of using transformers for clinical trial data?
Yeah, good luck with that. You're going to get thousands of results with those keywords, but most will be totally irrelevant.
Right. You end up spending hours just sifting through noise because the system can't understand your intent. It can't tell you, hey, this paper hits your first 2 points, but not your third.
I've been there.
Yeah.
So that's the first failure. What's the second?
Fragmentation. You're forced to stitch together your own workflow. You use, say, Semantic Scholar to find papers, then maybe connected papers to see the graph. Then you have to manually export everything to Zotero or Mendeley to organize it.
And nothing talks to each other.
Nothing talks to each other. There's no single system that bridges that entire life cycle, from discovery all the way to continuous tracking.
So WisPaper is trying to be that unified system, closing the loop.
That's their whole pitch. The 3 modules, search, library, and feeds, are designed to create a continuous cycle. Search feeds the library informs the feeds, and the feeds spark new searches.
Okay, let's start at the beginning of that loop then. Discovery, the scholar search. They talk about having 2 different modes.
They do. You've got quick search and deep search. Quick search is pretty much what it sounds like. It's for when you have a concrete target.
A specific paper title and author.
Exactly. You want a response in milliseconds. And it gives you all that rich context right away. Affiliations, venue prestige, citation counts, and importantly, a one-click button to add it to your library.
Simple, efficient. But the real innovation is the other mode.
The real innovation is deep search. This is where they shift from just matching keywords to having an AI agent, the WisModel, actually reason about what you need.
Okay, so how does this agent actually, orchestrate that? It's not just a black box you throw a query into, right?
No, it's a very structured 2-stage process. First up is the query understanding stage.
So it's figuring out what I really mean.
Precisely. It takes your natural language query, which can be messy, and it decomposes it. It builds this structured checklist of weighted validation criteria.
So it's turning my vague human question into a standardized, machine-readable checklist before it even starts looking at papers.
That's the crucial first step. And once it has that checklist, it moves to stage 2. The paper validation stage. This is where it actually evaluates papers against each item on that list.
Okay, let's make that concrete. The paper uses the example query. How do transformer models handle long sequences efficiently?
Right, so a keyword search just looks for transformer and long sequences.
But the WisModel agent is smarter.
Much smarter. It breaks it down. Criterion 1 might be, Does the paper discuss a novel architecture? Criterion 2, does it address the challenge of long sequences? And criterion 3, does it propose methods for efficiency?
And for each paper it finds, it gives a verdict on each of those criteria individually. It doesn't just say yes or no.
Exactly. A paper might be a perfect match for the architecture part, but maybe it only, mentions efficiency methods without going deep. So that would be a somewhat support.
And what's really cool is that you, the researcher, can actually step in and edit that checklist the AI made.
Yes. It's collaborative. You can refine the criteria to narrow the search so you're still in control. The agent does the heavy lifting, but the human provides the high-level judgment.
Okay, so the search part is this powerful hunter-gatherer, but then you need a place to store and organize everything. That brings us to the library and the feeds.
Right, because if you're aiming for long-term productivity, you can't have all your knowledge scattered across different apps. The library module is meant to be that single source of truth.
It's trying to replace Zotero, Mendeley, and just a random folder of PDFs on your desktop.
Basically, yes. It gives you the organizational tools you'd expect, like hierarchical folders, but it's tightly integrated. You can pull papers in from a PDF upload, from your search results, or from the AI feeds.
And it's not just for storage, right? It's for active work.
Yes, that's a key point. It has an integrated PDF reader. It can generate AI summaries to help you quickly vet a paper, and you can make your annotations right there.
And then when you're writing, you can export your citations with BibTeX or sync with other tools if you need to.
So it tries to be the central hub for your accumulated knowledge.
Okay, what about the other side of that loop, the AI feeds? This is tackling what, for many people, is the most draining part of research. Just trying to keep up.
It really is. I mean, you hear about researchers spending 1, maybe 2 hours every day just scanning RDIS. The AI feeds module is designed to automate that away.
But how do they keep that precise? Because, I don't just want my feed to dump the entire CSLECL category on me every single morning.
They use what they call a dual-layer filtering system. The first layer is broad, like those RCIV categories you mentioned. But the second layer is where the magic happens. It's a hyper-specific semantic match.
Give me an example of that. What's hyper-specific?
So you could take the broad cs.cv computer vision category and then filter it down to only show you papers that match a description like novel vision language models from researchers at Google or DeepMind.
So you can combine topics with institutions or even specific authors you follow.
Exactly. And that's how it turns a fire hose of 50 papers a day into maybe 3 or 4 that are highly relevant to you.
And it learns over time, too.
Absolutely. The system watches your behavior. Every time you add a paper from your feed to your library, that's a strong signal. It's positive feedback that helps the system refine its recommendations for you.
Okay, let's pivot to the engineering. How did they train WisModel to get so good at this? This is where we get into the technical details.
Right. So the training process really mirrored the 2 stages of the deep search. They had 2 main objectives. The first was criteria generation.
Teaching the model to turn my messy question into that clean, structured JSON checklist.
Exactly. Just establishing that basic ability to translate intent into a structured format. But the second objective, that was a really crucial one.
Matching assessment.
Right. Training the model to actually look at a paper and accurately decide, does this fully support, somewhat support, reject, or is there just not enough information for a given criterion?
So how did they do it? What was the training procedure?
It was a 2-stage process. Stage 1 was pretty standard, supervised fine-tuning, SFT. You take a big pre-trained model and fine-tune it on your data to give it the basic reasoning skills.
But the secret sauce was in stage 2.
Stage 2, that's where they used group relative policy optimization, or GRPO.
And this was applied specifically to that matching assessment task.
Yes. You can think of it like this. A lot of LLM training is just about getting the right answer. But here, they needed the model to understand the shades of gray. GRPO is a form of reinforcement learning that rewards the model for how closely its judgment matches the nuanced judgment of expert human annotators.
So it's not just about being right or wrong. It's about learning to think like a PhD student who is screening papers.
Perfectly put. And they validated this on a really solid data set, nearly 3,000 real multilingual queries annotated by PhDs from 10 different fields. Computer science, medicine, psychology, so it's broad.
Okay, let's talk numbers. The results. On that first objective, criteria generation, how did WisModel do?
It was state-of-the-art. It hit 94.8% on semantic similarity and 67.7% on Rougeol. And that Rougeol score is important
Why is that?
because it measures structural similarity. It means the AI wasn't just getting the concepts right, it was structuring and phrasing the criteria in a way that was very similar to how a human expert would.
So it's good at standardizing the request, but the real test is the second objective, the actual screening accuracy.
And this is where it just blows everything else out of the water. Its overall accuracy was 93.70%, which is more than 20 points higher than the next best model. The baselines were okay at the easy stuff.
The black and white cases. Full support or reject.
Right. They could handle those. But it's that somewhat support category that's the really interesting one.
The essential gray area.
That's the one. That's the gray area where all the baselines just fall apart. This is where you see the limits of current LLMs.
How badly did they fail?
I mean, it was dramatic. Gemini 3 Pro, a very powerful model, only achieved 15.9% accuracy on those somewhat support cases.
Wow. So it was basically guessing. That means it would have thrown out almost 9 out of 10 partially relevant papers.
Exactly. All those papers that might have a useful related method or some interesting peripheral data gone, that's a massive loss of efficiency.
And WisModel.
Thanks to that GRPO training, WisModel hit 91.82% accuracy in that exact same difficult category, that huge gap. That's the core value proposition. It finds the papers that require your expert human judgment and puts them in front of you.
So to wrap this all up, what does this mean for you, the researcher listening to this? It seems WisPaper is moving way beyond just keywords.
It is. It's offering a workflow that's centered on reasoning. It acts like a specialized assistant that automates the most boring and time-consuming part of research, which is that deep semantic screening.
And if you look at the bigger picture of AI in science, it's positioning itself in a really smart way.
I think so. It's not one of those AI scientist systems that's trying to replace the researcher entirely. It's focused on augmenting human control. The whole system is designed to empower your judgment, making it a true co-pilot.
That augmentation approach feels much more likely to be adopted, especially in really specialized fields.
I agree. And that, I think, leaves us with a really interesting thought to chew on. The big success story here is GRPO and its ability to teach the model how to handle that ambiguous, somewhat support category.
So the question is, how transferable is that?
Exactly. How transferable is that GRPO methodology? Could you use it for other complex agent tasks that aren't just about binary right or wrong answers? Think about, say, auditing code for subtle bugs or analyzing legal documents for precedent. Those are all tasks that live in the gray area, so that's something for you to mull over.
And if you want to dig into the details of GRPO or see the full evaluation tables for yourself, you can find the paper online. It's WisPaper, your AI Scholar search engine, by Li Zhu and colleagues.